Let's find the critical number of ln of x to the power of 2 minus 1. First we will differentiate. Then you can observe that this can be 0 where x equals 0. But you can also observe that the derivative is undefined at x equals plus minus 1 because then the denominator is 0. But we are not done yet. This will be meaningless unless I will check that x equals 0, x equals plus minus 1 are in the domain of the function g. So don't fall in the trap. You would like to believe that those are critical numbers, but I have a surprise for you. All those are not in the domain of g. Let's find the domain of the function. It's ln, so x to the power of 2 minus 1 has to be greater than 0. Write this down, do the analysis on the real line, and you see definitely that 0, negative 1, and 1 are not in the domain of the function. So we can conclude that here is another function that does not have critical numbers. And this is obviously wrong. There's a different way to check if those numbers are in the domain of g. You can just plug them in and to see that if you plug 0 or 1 or negative 1, x to the power of 2 minus 1 is not greater than 0. So you don't have to do all this analysis on the real line because we really don't care in the domain of the function so much. We more care to show that those numbers are not in the domain. So you just try and you bet it's a big no-no. Let's do this problem. First we differentiate and always simplify. So first of all, I want to look where the derivative is 0, and it is 0 where x equals 0. And the other kind for which the derivative does not exist, but it's in the domain of the function. If you observe plus minus square root of 10, both of those are in the domain of the function, but they are not in the domain of the derivative. What can we conclude? We can conclude that the critical numbers are 0 and plus minus square root of 10. And the critical points are always the critical number and then the value of the function at that point. So we get 0 and square root of 10 minus 0, which is square root of 10. And when we plug plus minus square root of 10, we get that f of x equals 0. So we get also radical 10, 0 and negative radical 10, 0. Let's do the same for the function f of x equals absolute value of x. First of all, the domain is the set of all real numbers, but it may be not differentiable because it's a piecewise function. So the first thing to do is to write it as a piecewise function. Let's differentiate the function. Where x is not 0, when it's not a suspicious point, I have no problem. I can just go ahead and differentiate each one of those branches and I get 1 and negative 1. So it's very clear that when x is not 0, we cannot get any critical numbers. The derivative of this function is never 0, so the only thing left to do is to check if it is differentiable or not. But we know if you look at the graph or if you remember that there is a corner. because the slope changes from -1 to 1 and x equals 0. So it's not differentiable at x equals 0. So the only critical number is 0, and the only critical point is 0, 0. I want again to show the graph, because we know how to inspect graphs, and you can see here the slope is 1, here the slope is -1, and there is a sharp corner at x equals 0, so it's not differentiable, but it's very easy to check. Obviously, absolute value of 0 is 0, so x equals 0 is in the domain of the function, and that's why there is a critical point at 0, 0. So let's do another piecewise function. So first we differentiate this function, and we never include in the domain of the differentiated piecewise function the suspicious points, because you know that in these points there is a change, drastic change in the function, and the function it's not necessarily differentiable there. So here it's 5, and I want this to be 0, but it will never be 0, because it's 5. And here, okay, I have to solve that. So let's do the algebra, and we get two answers. We get x equals 1 and x equals -2. But if you look, the domain of this branch is that x is less than 0. So x equals 1 is not in the domain of this piece, and we have to take this one out of the picture. So we get that x equals -2 is a critical number of the easy type, the type for which the derivative is 0. But now we have to see and to check if the function is differentiable at x equals 0. So the derivative from this side is 5, which means that the slope of the graph is 5. From the other side of the 0, we have to substitute 0 in the derivative, and we get -12. We see a corner at x equals 0. So x equals 0 is also a critical number of this function. So we can conclude that the critical points are -2 and f of -2, which is -220. Okay. Just substitute this in the function, please, in the function, not in the derivative, in the function. And 0f of 0, which is 0, 0. Let's find the critical points of the function fx equals e to the -x sine of x on 0 to pi. The domain of this is all real numbers. If you can see, it's a product of two functions which domain all are. Here is the derivative using the product rule and the chain rule for the e to the -x. We try to combine it like this, because we need to write this as product of term and solve for 0. I would like this now to be 0, and this guy is never 0. So I have only to solve this one. So we have two critical numbers between 0 and 2 pi, which is pi over 4 and 5 pi over 4. The critical points are, you have also to substitute in the function, and you get those critical points.